GeoWave is a framework designed to solve the scalability issues of processing spatial and spatiotemporal data by bridging the gap between geographic information systems and distributed computing clusters. The algorithms that GeoWave uses to index data ensure that features of similar latitudes, longitudes, time values, altitudes, or any other attribute you care to index by are stored physically close together in the distributed key value store. This preservation locality lowers the time needed to process your data by multiple orders of magnitude. We've also integrated GeoWave and other popular GIS frameworks so you can take advantage of its innovative solutions and massive scalability benefits in the software that you're already comfortable with. Here, we're using the GeoWave command line functionality to add a new layer to the popular open source map server software, GeoServer. Traditional methods for storing and retrieving geospatial datasets can typically process millions of observations, but become untenable in the hundreds of millions range. The GeoWave framework, on the other hand, is designed to efficiently query, process, and render billions and even trillions of observations. To get a better perspective on the difference between millions and billions, $1 million in $100 bills looks like this and weighs about 10 kilograms or 22 pounds. Compare that to $1 billion in $100 bills, which looks like this and weighs 10 metric tons. With that in mind, let's see what we can do with GeoWave and data from 1.3 billion taxi trips provided by the New York City Taxi and Limousine Commission. In this demonstration, we've extended GeoWave to create an application that returns an estimated length of time and fare for a taxi ride between a selected pickup and drop-off location based on historical trips taken from similar locations. In this case, we index the data with respect to 5 different dimensions: latitude and longitude of both the pickup and drop-off locations, as well as the time of day. This gives us the ability to provide an interactive user experience despite the significant size of the dataset. To give you a sense of scale here, we can show the point data on this map. 1.3 billion taxi trips becomes 2.6 billion points on our map, as each trip is both a pickup and drop-off location. Under normal circumstances, it wouldn't be possible to render that amount of data on this web map. However, GeoWave uses a spatial subsampling algorithm to display the maximum amount of data possible per map pixel, without wasting processing power on data that would otherwise just be hidden. GeoWave also has a number of built-in analytics. We can use the same dataset from our demo and produce a heat map using the kernel density estimation algorithms in GeoWave. You can see a large hotspot here in Manhattan, as well as at each of the area's 3 major airports. As we zoom in, you can see more detail in the heat map and many of the differences between individual blocks. We can also set up our map to visualize the difference in density of various attributes. In this case, we show the difference between the densities of the pickup location in blue and the drop-off location in red. If you'd like to learn more about GeoWave, you can find us on GitHub at locationtech/GeoWave or send us an email at geowave-dev@locationtech.org.